So when I'm graphing a trig transformation, what I want to do is start by taking my equation and then figure out what my mapping notation is going to be. That mapping notation is going to be really important when I go to check my graph at the end to make sure that all my points are ending up in the right spot. Okay, so the first thing I want to do when I'm given a trig equation is to make sure that inside the bracket that we've factored out any of the coefficients in front of the x. So I have to pull the 2 out, and I'm left with x plus pi by 6, because pi by 3 divided by 2 is pi by 6. And then I'm ready to do my mapping notation. So I'm taking a point xy on my original cos graph. So if you're starting with sine, you would use sine, but we have a cos here, so we're going to use cos. And remember, our regular cos graph starts at 0. And, well, it actually goes on forever, but we usually start it at 0 for one full cycle. And then its maximum is 0, 1. It starts at its maximum. And then at pi by 2, it's at 0. Pi, you're at -1. 3 pi by 2, 0. And then one full cycle at 2 pi, you're back to 1. And you can keep going either to the left in the negatives or to the right. Every pi by 2, you're going to have a key point. And what we're going to do with all of those key points is we are going to map them to our transformed function. Remember that inside the bracket, if there's a 2, it's actually a horizontal compression by a factor of 1 over 2, so x divided by 2, or you can think of that as 1/2 of x. And then we're shifting it, phase shift, pi by 6 to the left. And our y coordinate, we're doing 4y minus 1. Okay, so the amplitude, you'll recall, is the half the distance from the max to the min value vertically, and that's this number here in my equation. So 4 is the vertical stretch, and it also corresponds to the amplitude. And the vertical translation is -1 down. So we're going to figure out where the max, the min, and the center of my graph are going to be, the transformed graph, and we're going to put that onto our scale. So the amplitude plus the vertical translation will give us the maximum value. So we're starting at -1, and we're adding 4 to it, or vice versa, it doesn't matter. Our top value, y value, is 3. And then if I start the vertical translation, -1, and I subtract 4, I end up at -5. And let's do a quick check. 3 minus -5. There's a difference of 8 vertically between those two values, and 8 divided by 2 is 4, the amplitude. So now I can put those onto my graph. So I like to actually mark those key values right on there. So I put my maximum at 3, my center at -1. I like to put a dotted line to remind myself where that line y equals -1 is. And then at the bottom there, -5 will be my lowest value. So -5 will be on there as the lowest value. Okay, so once I have those 3 vertical values on there, I will know where my key values on the graph are going to be that I'm aiming for. So now I want to go back and look at the horizontal. So in my equation, what you'll notice is that we have a c value of 2. That's the number that we're dividing x by. So I take my standard period of 2 pi, that's for a regular sine or cos graph, and I divide it by whatever the c value is. So if it's multiplied by 2, I divide by 2. So the period is pi, which means that we've been horizontally compressing the points by a factor of 1 over 2. So you're dividing the distance between the points in half. And then it's really important for your scale that you figure out what happens every quarter of a cycle where there's a key point. So take whatever the period is, so pi this time, and divide it by 4. So every pi by 4, you're going to have a key point, which hopefully makes sense because you want it to be a half of the distance of the points on your regular cos graph. So this period divided by 4 is very important calculation, as well as this calculation here. Make sure you take a moment to do that. Also, when you're figuring out your scale, you want to look at what your phase shift is. We are moving pi by 6 to the left. And we want to know what common denominator works for pi by 4 and pi by 6, so that we can figure out how much each box should be worth. So hopefully you can see that that would be 12. So the common denominator is 12. So my scale is going to be pi by 12. So just think of this as a quarter and a sixth. Your common denominator that would work nicely would be 12. So that's good for your scale that you're setting up. So then what I'm going to do is on my graph, because I want to be really precise here, is I'm going to start at 0 because it asked me up here to graph between 0 and 2 pi. You have to make sure that you pay attention. This goes on forever, so you really have to know what piece of the graph we want to look at. Well, it says here between 0 and 2 pi. So if I start my graph at 0 and I go to 2 pi, I wanted every box to be pi by 12 or 1/12 of pi. So what I'm going to do is I'm just going to count over 12 boxes and make that pi, and 12 more boxes and make that 2 pi. Halfway in between would be pi by 2 because it's halfway, and halfway in between pi and 2 pi would be 3 pi by 2. So I'm just adjusting my scale so that I'm working nicely with that common denominator of 12. Okay, so once I've done that, I'm ready to graph my first function. So I'll do this one in green. So I want to graph y equals 4 cos 2x minus 1. So I know where its maximum, its minimum, and center is, and I know cosine starts at the top. So I'm going to graph it without the phase shift first. So cosine starts at the top, which was 3, and every pi by 4, I should have a key point. Well, how many boxes is that with my scale? Well, my scale was pi by 12. So how would I convert 1/4 into something out of 12? Well, I had to multiply by 3. So that means it's going to be 3 boxes with my scale. So I'm going to count over 3 boxes, 1, 2, 3, and I'll be to the center of my graph. 1, 2, 3 at pi by 2, I'm down to the bottom. 1, 2, 3, back to the center. And then pi, I'm back to the top. So one full cycle now fits inside pi instead of 2 pi. Okay, and I'm going to stop there because now what I want to do is pick a new color. And I want to now incorporate the pi by 6 to the left. Pi by 6 is negative 2 pi by 12 if I get a common denominator. So I'm going to be shifting everything 2 boxes over. So this point here would shift over 2. I'm not going to mark that on because that would be off of the graph before 0. This one I'm going to shift over 2. So it's now at pi by 12 when I shifted over 2 boxes. This one I'm going to shift over 1, 2 to the left. This one, 1, 2 to the left. And this one, 1, 2 to the left. So then that is now the graph that I'm looking for. And just make sure you neatly label everything. That's really important here. And the pattern just continues. So all we have to do is keep counting over 3 boxes and continue the pattern until we hit 2 pi. So we're going to have back to the center. So we're going to count over 1, 2, 3 would be here. And then 1, 2, 3 would be down at the bottom. 1, 2, 3, so back here to the center. And 1, 2, 3, back to the top. And that makes sense because remember that it should be 2 boxes over from where I started. Its maximum's not at 2 pi, it's 2 boxes to the left of that. And then I just continue the pattern. So the next key point would actually happen off the graph down here. So I'm just going to sketch that until I hit 2 pi. Now I can check some of my key points with my mapping notation, which just a reminder, I'm taking a point on the original and I'm ending up with 1/2 of x, or x over 2, minus pi by 6. And the y value is being multiplied by 4, and I'm subtracting 1. So let's just take one of our sample points. So let's pick pi and -1. Let's see what happens to that point. So pi, -1 on my regular cos graph. It's divided by 2, so now it should be at pi by 2 minus pi by 6. And 4 times -1 is -4, minus 1 is -5. So this is where the minimum happens. And common denominator of pi by 6, I would have 3 pi by 6 minus 1 pi by 6. So I end up with 2 pi by 6 or pi by 3, -5. And I'm just going to map that one point to make sure to end up. You could map 5 points to check they're all in the right point, but let's just check that one. So pi by 3 would actually be 4 pi by 12. So 1, 2, 3, 4. And we're going to go right down here and just check. Yep, that's the point that I was looking for. Oh, actually, I didn't reach quite far enough. It should have been down there, my minimum was actually down here at -5. I didn't go quite far enough, so make sure you do double check that as well. So let me just regraph that really quickly. Just the bottom, I didn't make it far enough down. Just make sure that you reach all the way down to that minimum, which is -5. And all the way down here to -5, just to make sure it reaches all the way down there. And that's it, we're done our graph.